Okay, so what we're going to talk about today is something called rational exponents. So what we're going to do is we're going to find how radicals and exponents are related because they are directly related. Okay, rational exponents means that the exponent is going to be written as a fraction. I know how much you guys like fractions. It's really not very difficult. Okay, so let's go to the next page. We're going to substitute the values in for A from the list 1, 4, 9, 16, 25, and 36, and we're going to write a conjecture on our paper about what we see. I'm not sure that this is going to work. We can hope. So if I take A and make it 4, possibly, yeah, and not like that. This doesn't like me. It's not working for me. That didn't work. Yeah, you don't really need to be over here. Be over on this side, on the right side. You're going to change the base. Where it was 1, make it 4. Sorry about that, guys. Okay, so 1 to the 1/2 was 1, right? 4 to the 1/2 is 2. Okay, so what's the next one on our list? 9. So I'll go ahead and change that 4 to a 9 and see what 9 to the 1/2 power is. You only need to change the one on the right-hand side of the screen. I don't know. Hit Control Z if you took it away by accident. Control Z will bring it back. Okay, so now I'm going to take this. I'm going to make this a 9, and we get, okay. Okay, so we know 9 is 3. 16 will be 4. Very good. What do you think 25 is going to be? Why do you think it's going to be 5? It's going to be the square root. Okay, so is that our conjecture? We're thinking that anything to the 1/2 power becomes what? It's square root. Very good. Okay. Excellent. So we think, see if I can write this legibly, that maybe, or not, x to the 1/2 power would equal what? Or a to the 1/2 power? A to the 1/2 power, what's it equal? Square root of a. Okay, so that's our conjecture, right? So does it work for any value? If I had a to be 36, what would a to the 1/2 be? 6. If a were 64, what would 64 to the 1/2 be? 8. Okay, so anything to the 1/2 power is the square root. Okay, question. What's the index? 2. What's the power? 1. Right? It's a to the first power. Where do you see the 2? Where? Where? And give me a word for bottom. Denominator. Okay, it's in the denominator. Where's the 1? Numerator. So the power is in the numerator. The index is in the denominator. Well, we're going to find out. The index is the denominator, right? The numerator is your power. So we're going to see if that holds true on the next page. Are you ready? Say yes. Okay, next page. Now we're dealing with 1/3, right? To the 1/3. Okay, so we're going to start with the value of 1. What's 1 to the 1/3 power? It's 1. Okay. Next one we want to go to is what? Our, follow the list. 8. 8 to the 1/3 power? 2. Next one. 27? 3. Are we finding a pattern? 64 is going to be 4. Very good. And 125 is going to be 5. So what's my conjecture? Very good, Brittany. Okay, so anything to the 1/3 power is the cube root. Excellent. Okay, so again, what's my index? 3. My index is 3. What does that match up with? in my exponent, the denominator. And what's my power? 1, and that matches up with my numerator. So is it following that same pattern? Yeah? Okay, so let's get a little bit harder. Okay, so 2/3. 2/3. So what's 1 to the 2/3 power? 1. 8 to the 2/3 power? 4. 27 to the 2/3 power? 9. No. 64 to the 2/3 power? 125. 125. Yes. Okay. Now, we just got done talking about the first two, right? We said the square root was to the 1/2, right? We said 1/3 became the cube root. So what's a to the 2/3? Yeah. Okay. So what we did is we took my value and we squared it, and then we took the cube root. All right. So if we think about 8, right? It would become the cube root of 8 squared. Good. Cube root of 64 is 4. So do you see how that works? It takes a little getting used to. Okay, so if we have the cube root of 27 squared, you're going to figure out what 27 squared is, and then take the cube root. What do you think? We're going to do a lot of practice with it. Okay. Exactly. Denominator of the rational exponent is your index, numerator is your power. Okay. So let's see what our general rule is. We're going to skip a page and go to this one. A to the m over n. How would I write that as a radical? M or n? Nancy or Matt? Nancy. Okay, so the nth root of, good, I want you to say that, please. Everybody. Okay, you have to know how to say these things correctly, right? We don't say the 3 root, we say the 3rd root or the cube root. We say the square root, not the 2 root. Okay, so you have to learn how to say it appropriately. This would be the nth root of a to the m. Okay, so let's do a whole bunch of practice. Take out your packet. Open up to page 20, please. 20. Okay, so 1a, this one should be quick and easy, right? 36 to the 1/2 power is the same thing as? Good, square root of 36. Which is? And? Yeah, don't forget. Even index, positive, negative. Try B. Even, positive, negative, odd. Leave it alone. How am I going to rewrite B? Busy. Which is? Great. Nope, odd index. It only stays positive, whatever it is underneath the radical. Okay, why don't you skip to D? We're skipping it. I want to make it harder. Do we like negative exponents? No. How do we get rid of them? How do we get rid of negative exponents? Yeah. 1 over 100 to the 1/2 power. Yeah, Yeah. This is 1 over the square root of 100, which is 1/10. What do you think? Not bad, right? These ones are pretty simple. Okay, so let's get a little bit harder. Let's get 2a. 2a, no calculators, no touching. Okay, 8 to the 2/3 power. How would I write this again as a radical, guys? Good, cube root of 8 squared, perfect. Cube root of 8 squared. Focus. Got to deal with what's on the inside. What's 8 squared? 64. 4. Good. What do you think? What's the index? 3. Is it even or odd? Right. Okay, so try number 4, or try number 2b for me, please. Bad kid. Okay, how would I write it as a radical, guys? Good, radical 4 cubed. 4 cubed is? Square root of 64 is? Plus and minus. Excellent. We okay? Not bad, right? Okay, try E for me, please. Okay, how do I get rid of the negative exponent? Okay, how do I write it? Okay, what's 4 to the 4th? 5th? Whoops. What's the square root of 1024? Excellent. It would be. Okay, how we doing? Pretty good? Okay, let's move on. Let's go to the next page. Sure. And look at 6. Number 6. Okay, the monomial 4x raised to the 5/2 can be written equivalently as, what's being raised to the 5/2 power? The 4 and the x, right? Both of them. Okay, so when I go and change this to a radical, how would I write it? How would I write 4x to the 5th? 4 to the 5th, x to the 5th, or 4x raised to the 5th in parentheses. Why did I put parentheses around it? Because that 5th has to go to both the 4 and the x. Okay, if you don't have the parentheses, it's wrong, because what you're saying is 4 times x to the 5th. It's not the same thing. Okay, so we need to figure out what 4 to the 5th power is. Yes, please. It is. So this becomes 1024x to the 5th. Okay. Now you should know what the square root of 1024 is, because we just did it. So that 32 comes out, and I have square root of x to the 5th. Now generally, we would keep going, right? We know how to break down the square root of x to the 5th, but they've already got that answer for us. Okay. But since I like to make you guys work, how would you break down the square root of x to the 5th? Excellent. Yeah, sorry, I lost my 2. Okay, square root of x to the 4th? Yeah, so you get 32x squared square roots of x. So that's what it would be fully broken down. Okay. All right, why don't you try 7 for me? I'll pause here. How am I going to rewrite this? Yeah, 1 over Very good. Don't forget those parentheses. Now what? 1 over the cube root of 8x. Great. What's the cube root of 8? So 1 over 2 cube roots of x, which is choice 1. Do I like leaving it like that, though? No idea. Do I like the cube root of x? Do I like leaving that in the denominator? Does anybody know how I would get rid of it? The cube root of x in the denominator. Let's talk about this as a little side note. If I have 1 over the cube root of x, right? Generally speaking, we don't leave radicals in the denominator, right? We usually multiply by the conjugate to make it go away. But the conjugate when I'm dealing with indexes other than 2 is a little bit different. If I gave you 1 over the square root of x, you guys would have no problem with that. You'd say multiply by the square root of x over square root of x, right? What's the square root of x times square root of x? Square root of x squared. What's the square root of x squared? So that's why it works, right? It simplifies out. So if I'm talking about the cube root of x, multiplying by the cube root of x again isn't going to give me a perfect cube, is it? So what would I have to multiply by? What would I have to multiply x by to make it a perfect cube? I didn't lose a 2. This is just a side note. Not quite. Remember, when I multiply variables, what do I do with their exponents? I add them. So what would I have to the cube root of something? It has to be the cube root of something. So the cube root of x times the cube root of x squared, why x squared? What's the cube root of x times the cube root of x squared? X cubed. Cube root of x cubed. What's the cube root of x cubed? X. Okay, so those ones are a little bit different. When you're dealing with indexes other than 2, you have to make sure that you are multiplying by something that's going to make it simplify down to a non-radical. Okay, so that's just a little side note. We'll do more work with that. Can I make this go away? Looking for my homework assignments. Go to 23 for me, please. Your homework is 20, 21, 23. Yeah. Oh, it's hot in here. Okay. You guys ready? When you raise a power to power u, multiply. So this becomes x to the no, we'll raise power to power 12 over 5. This is 4 over 1 times 3 over 5, dear. Okay, make this into a radical for me. Make it into a radical for me. No, 5th root of x to the 12th. Got to break it down. Excellent. X to the 10th, x squared. Fifth root. Yeah. Okay, good. Okay, I want to look at D as well. What's wrong with this picture? What's the index? In the numerator, it's a, and in the denominator, it's a 2. So can I divide them the way they are? You can't, right? I have to have the same index. So when something doesn't work with the radicals, what we do is we take it and we turn it into a fractional exponent. Okay? So you're going to have to be able to go back and forth between the two. All right, so do I have common basis? What do I do with the exponents when I'm dividing? Okay. What does this become? X to the negative 1/6. You have to have common denominators when you add and subtract fractions. Yeah. Okay. So you have to go back and forth between the two. Radical to exponent, exponent to radical. Okay. Now, if you look at this one, notice two of them have exponents and one of them is written as a radical. What do you think they should all be written as? Exponents. And the reason being is because this one's going to become a cube root if you do that, right? This one doesn't get changed into a radical because it's x squared, it's not x to the 1/2. So you would have to take this and switch it up, okay? And then you're just dealing with your rules of exponents. When you multiply variables, you add their exponents. When you divide, you subtract, okay? So again, homework is 20, 21, 23. You guys need to do these ones, okay? You need to practice them. I won't be after school. None of the teachers will. We all have a mandatory meeting, okay? So I apologize, but I will be available during lunch outside of the cafeteria. Okay, okay?